From the observation window of the International Space Station, Earth feels almost within reach, a living sphere of blue and white, pulsing like a heartbeat framed in aluminum and glass. The planet's limb drifts past, the aurora twisting above it like curtains of green fire. You can almost sense the strain once carried by the shuttles that tore through the thin edge of atmosphere on their way home, their skins trembling with the invisible weight of reentry, every rivet bearing forces mapped and mastered by human minds. We've built machines that skim the surface of oceans, that sip sunlight, that descend through flame and fury to return to the world that made them. Yet none were more improbable than the one that never came back. A small, quiet craft that slipped free of the sun's light before home computers existed, before the internet bound our voices together, before most of us were born. It does not circle any planet now. It sails through the dark between stars, carrying the patience of an age, still whispering to us across the void. This is the story of Voyager 2, twin to Voyager 1, born of the same audacious idea, one of the last human voices still speaking from beyond the sun's protective breath. In 1977, NASA threaded a cosmic window that opens once every 176 years. The outer planets had fallen into a rare alignment, a celestial chain discovered by Gary Flandreau using nothing more than a pencil and a slide rule. It offered a pathway where a spacecraft could use each giant planet's gravity as a slingshot to the next, turning what would have been a journey of decades into one of just 12 years. Two spacecraft were built for that grand tour, Voyager 1 and Voyager 2. Identical twins, but destined for different fates. Each carried cameras, spectrometers, and magnetometers, instruments to see, to listen, to measure. And each carried a gift. A golden record etched with greetings in 55 languages, the rush of wind and surf, the beating heart of a mother and child, and music spanning centuries, from Bach's precision to the rhythm that made Carl Sagan smile. Voyager 1 took the inner lane, bound for Jupiter and Saturn. Voyager 2 followed, and then kept going. It would become the only emissary ever to visit Uranus and Neptune. At Jupiter, the Voyagers revealed a system alive with power, belts of storms and moons that were worlds of their own. Io erupted with sulfur volcanoes, a restless body of fire. Europa's surface fractured, hinting at an ocean locked beneath its shell of ice. At Saturn, they turned the rings into laboratories, discovering braids, gaps, and ripples shepherded by unseen moons. Voyager 1's journey ended there, turning its cameras homeward to capture a portrait of Earth, a pale blue, a tenth of a pixel wide, a fragile reminder of everything we are. But Voyager 2 pressed onward into stranger light. Uranus greeted it with silence and a riddle. The planet lies on its side, tilted 98 degrees, its poles where most worlds have equators. Seasons there tumble end over end. As Voyager 2 swept past, it sent back images painted in cold, a world of methane blues and hidden clouds, its mysteries only revealed by coaxing data from faint signals. 2 new rings appeared out of glare. 11 new moons stepped into view. The cold was merciless, more than 350 degrees Fahrenheit below zero, where nitrogen and methane are no longer gases, but frost and shadow. As it crossed the planet's magnetic field, Voyager 2 detected something strange, a vast bubble of magnetized plasma, detached and drifting, a plasmoid large enough to engulf a world. The magnetic field itself was tilted and offset, not anchored at the poles as on Earth, but wandering, unpredictable. It hinted at a restless dynamo deep within, flickering and peeling atmosphere away in invisible streams. Those images were stark and beautiful, and unique. No other craft has seen Uranus up close. None have since. Beyond Uranus waited Neptune, a darker, deeper blue, where winds roar faster than sound. Voyager 2 found a great dark spot spinning like a storm's eye, and clouds of ice racing through the upper atmosphere. Its magnetic field echoed Uranus's oddity, tilted, twisted, and misaligned. And then came Triton, a moon that should have been frozen and still. Instead, it breathed, Voyager 2 captured geysers of nitrogen spraying into space, painting dark streaks across its pink surface. Beneath the crust of ice and fissure, warmth lingered, maybe enough for an ocean hidden and enduring, like the secret seas beneath Europa or Enceladus. Voyager 2's brief encounter left behind data still fueling discoveries decades later. The first and last looks at those distant worlds. It could have ended there, a triumph already complete. But the Voyagers were built with a kind of stubborn immortality, machines that refuse to stop. Beyond the planets lies a boundary, the heliopause, where the solar wind thins and gives way to the plasma between stars. Once drawn as a simple line, we now know it as a weather front, a turbulent region that breathes with the sun's moods. Voyager 1 crossed it in 2012. Voyager 2 followed in 2018, approaching from another direction and giving us a second perspective. The data told a story in 3 clear parts. The plasma density around it rose sharply, proving it had left the sun's bubble and entered the galactic sea. The stream of cosmic rays intensified, no longer deflected by the heliosphere's pressure. And the magnetic field, instead of pivoting sharply as predicted, draped itself smoothly, strengthening but keeping direction, like wind flowing around ship's hull. Then the instruments began to hear, not in sound, but in the oscillations of electrons translated into frequencies we could interpret, a faint, steady hum. The song of interstellar space itself, alive with ripples from ancient supernovae and the slow churn of matter that will one day become new stars. For the first time, humanity had continuous measurements of plasma beyond the heliopause, a baseline for the interstellar medium, a clearer picture of the space between solar systems. And in that data lay a revelation. The void is not empty. It is an ocean, vast, cold, but alive with weather that drifts between stars. The miracle behind that discovery was not luck, but endurance of engineering and faith. Voyager 2 is now so far away that its radio signals take more than 18 hours to reach Earth, and another 18 to return. The Deep Space Network, with its dishes the size of buildings, listens for a signal powered by just 20 watts, less than a household light bulb. Decades ago, the team knew the plutonium inside its generator would cool, its power fading with each year. They made plans that once seemed impossible, shutting down heaters, letting components operate in temperatures colder than ever tested. They powered off instruments, one by one, preserving just enough current for the plasma sensor and magnetometer. They rewrote code to work around radiation scars in its memory. They revived thrusters that hadn't fired since the Reagan era to keep its antenna pointed home. Every whisper it sends back is a triumph. Every graph of particle density or magnetic flux a small miracle of persistence. The data is leaner now, the bits slower, but they still come. And each one adds to a symphony that will outlast the instrument that plays it. Voyager 2's legacy isn't only in its discoveries. It's in the way it reshaped how we explore. Its images of storms and rings and geysers changed what we ask of telescopes and spacecraft. They sparked missions like Europa Clipper and Dragonfly, each chasing the possibility of oceans beneath ice. They taught us that magnetic fields defy simplicity, that atmospheres misbehave in ways that can reshape worlds, that even small moons can harbor grand secrets. The Voyagers also forced us to see the heliosphere differently, not as a shell, but a living boundary that swells and contracts like a heartbeat. They replaced speculation with data, guesses with knowledge. And they gave us something deeper, the sense that our home star's influence has edges we can cross, and that crossing them is what we were meant to do. The golden record riding aboard both Voyagers is part of that message. A time capsule in a language that needs no culture, a format that never grows obsolete. It says simply, we were here, we listened, we imagined you might listen back. It defies the idea that nothing lasts. Someday, the last signal will fade. A quiet console, a blank screen, and a final shift change at mission control. The spacecraft will keep working in silence, unseen, still perfect in every way except the one we can no longer detect. It will drift for billions of years through the outer shells of our solar system, past the slow orbits of distant stars, its antenna forever aimed at home. And if, one day, some future intelligence finds it, deciphers the record, and listens to the music, they will learn that a small blue world once dared to speak, that it mapped storms and rings and the faint hum of plasma seas, that it used the gravity of a star to skip across a system, and then kept going simply because someone once decided that long enough was never enough. They will find our map, drawn from 14 pulsars, and perhaps understand that we hope to be found. But we don't need a listener to justify the act. Voyager 2 already did what mattered. It expanded the borders of the known and made the impossible tangible. It turned myth into math and math into memory. From the cupola of the space station, Earth still gleams close and fragile, a place worth every ounce of effort to keep alive and curious. From Voyager 2's vantage, it is a pale spark in an endless black sea. Both perspectives are true. Between them stretches a ribbon of radio, 18 hours long, carrying proof that our ocean has shores we can reach, if we dare. Voyager 2 will one day fall silent, but its path will not. Its influence endures in the missions it inspired, in the questions it sharpened, and in the quiet conviction, somewhere deep within us, that traveling is what we are for. That may be the truest gift of all, from a small, tireless machine, still moving, still teaching, still ours.